I can say it is circumstances for me, and it was a build-up of all other events, and mostly based on the opportunities I was looking forward to in my future life. And also, I can say it was an influence from friends. So, because right from high school, I was a mathematics and physics lover, but my teacher and my friends who were good in chemistry really influenced me to love chemistry. And my undergrad, I was influenced to major in chemistry because my friends who are graduating, they came to grad school here in the US. So it looked to me that if I want to go to grad school, maybe it's good I decide to do chemistry. And that, I think, kind of influenced me to major in chemistry. I did my master's back in Kenya. Right after my undergraduate, I did my master's. And then right after that is when I came to graduate school. On the schools, it's a bit difficult for us. And I had a good help from my advisor back home. So he had schools in mind. I really had no information about schools in the US. So he gave me 4 schools, and Michigan State was one of them. And I only completed application to Michigan State. And fortunately enough, I was picked. And that's how I ended up here in Michigan State. Yeah. Why chemistry? That's a hard question. But as I said, when you're going to school, usually we were trained like you have to have a positive attitude towards all subjects. You never know what you'll end up to. And for us back home, we really don't have a wide range of choices like professionally. So we have to equip ourselves with so many other things so that when you have a chance, you can pick from those things. So I chose chemistry over biology or physics because I majored in chemistry in undergrad, and I feel like for me to fulfill my dreams, I think I should just continue chemistry. So that's it. And when I came to graduate school, I just continued my chemistry, and specifically organic chemistry. Organic chemistry, as the name suggests, is you can say the chemistry of organic matters, but not really, because biochemistry is also there. Organic chemistry is the chemistry of majorly of hydrogen, the compounds that consist majorly of hydrogens and carbon. That's organic chemistry. Other chemistry, inorganic, is a chemistry of inorganic materials. Physical is organic, usually the physical properties that influence chemistry. And analytical basically is a conglomeration of all other chemistry, because you are analyzing all these bits of chemistry, analyzing organic, inorganic matters. So the major difference is organic chemistry, we are charged with the responsibility of building molecules, starting from simple molecule to very big molecules. That's organic chemistry. So this lab does carbohydrates. So we always call our lab as a sweet lab, because carbohydrates are sweet. And Professor Shufe Huang is in charge of this lab. And in our lab, basically we are using carbohydrates to understand the biology of cancer. So we make carbohydrates based on the knowledge that is already out there about the influence of how carbohydrates have influence in cancer. So we are using that to try and understand more. So we use carbohydrates to try and build cancer vaccines, and most of the majorly we use carbohydrates to do what we call drug targeting delivery to cancer cells. So that's what we do in this lab. So the magnetic iron oxide, just like other contrast, is a contrast agent. So contrast agents are very helpful when you're doing imaging. And when doing imaging, so imaging is one of the theranostic method that is used clinically to try and identify if you have like mostly tumor. So this iron oxide nanoparticle can be used as contrast agent, and so when they go into the body, you can easily track them. Okay, we use it as like just like a tracking device in the body, and we assume that the tumor will uptake more of this than the normal cell. And since the tumor environment is poorly developed, like the vasculature is not well developed, so they go there and they kind of get trapped. So once they trap, they get retained for longer than the normal cell. So when you go to image, when you see where there's a high accumulation of this contrast agent, and then it becomes suspect. Like that, it might be a tumor right there. Okay, and then you can go exactly to that location if you want to do surgery or whatever more studies to confirm that indeed that place is tumor. It's a tumor environment. So that is the importance of iron oxide nanoparticle.